Namaste all of you. Today we are going to learn the concept of indeterminate forms part 2, and earlier we had discussed about the L'Hospital rule to evaluate the limit as of the form 0 upon 0. So here I give some examples regarding 0 upon 0 form of the and how to evaluate the limit of given functions will be form of 0 upon 0. So we are trying to evaluate limit x tends to 0 x minus sin x upon x cube as a example number 1. So again I Tushar Bhatt welcome you all in our video lecture session. So here now we can try to evaluate example number 1 according to L'Hospital rule. My dear friends, remember L'Hospital rule is applicable only on the given function as of the form 0 upon 0. So first we check that the given function as of the form 0 upon 0 or not. If answer is yes, then we apply L'Hospital rule. If answer is no, then we can try to convert the given function into the form of 0 upon 0 at the point x equal to 0 or x equal to any arbitrary point a. So now we can try to calculate it. Solution. Here in general that limit we are consider as a L. So here L equal to limit x tends to 0 x minus sin x upon x cube, x minus sin x upon x cube. Here observe that if we talk about the numerator, substitute x equal to 0, we get 0 minus 0 because sin 0 is 0. 0 minus 0, so that is 0 upon. Substitute x equal to 0 in the denominator, 0 cube is nothing but 0. So that is 0 upon 0 form. So L'Hospital rule is applicable. L'Hospital rule is applicable. So according to L'Hospital rule, L equal to limit x tends to 0 as it is, differentiate numerator with respect to x as well as denominator with respect to x. So now differentiation of x with respect to x is 1 minus differentiation of sine with respect to x is cos x. Differentiation of x cube is 3x square. Then here we are not directly substitute x tends to 0 because here substitute x tends to 0, here cos 0 is 1, so that is 1 minus 1, 0. Again denominator 0 square is 0, multiply with 3, answer 0. So again that is a form of 0 upon 0. So we can not apply x equal to 0 directly in the given function. So according to the L'Hospital rule, again we can differentiate numerator as well as denominator with respect to variable x. So it will follows that L equal to limit x tends to 0, the differentiation of 1 is 0, differentiation of constant is 0, minus differentiation of cos is nothing but minus sine. So that is 0, here minus minus plus sin x upon differentiation of x square with respect to x is 2x, 2x into 3 equal to 6x. So answer is 6x. So that is equal to limit x tends to 0 sin x upon 6x. Check the denominator is not equal to 0, then and then answer will be in the form of finite number, but here denominator is 0 at the point x equal to 0. when we substitute x equal to 0, we get 0 into 6 answer 0, and numerator sin 0 is 0. Therefore, so that is again a form of 0 upon 0. So according to the L'Hospital rule, again differentiate with respect to x, numerator and denominator both. So limit x tends to 0 as it is. Differentiation of sine is cos x, and differentiation of 6x with respect to x is 6. So here observe that the L'Hospital rule is not applicable for this particular form, because when we substitute x equal to 0, we get cos 0 is 1 and upon 6, so that is 1 upon 6, that is finite answer, and at this point x equal to 0, denominator is not equal to 0, therefore we can substitute directly limit x equal to 0. So that is cos 0 upon 6. What is cos 0? Cos 0 is 1 upon 6. Then so our finite limit is 1 by 6, and we use the fact cos 0 equal to 1 equal to 0. Done. So that is all about when the given function is of the form 0 upon 0. Let us see the another 0 upon 0 form. Consider example number 2. Evaluate limit x tends to 0, 10x minus sin x upon x square. So how to evaluate it? The solution is like this. Solution here, L equal to limit x tends to 0, 10x minus sin x upon x square. So check by substituting x equal to 0 in the given function, the answer is finite or not. So here first we substitute x equal to 0 in the denominator, answer will be 0. 0 square is 0. As well as in the numerator, take x equal to 0, tan 0 is 0, sin 0 is again 0. So 0 minus 0, answer 0. So that is in form of 0 upon 0. So L'Hospital rule is applicable for finding finite limit for given function. L'Hospital rule is applicable. So according to L'Hospital rule, follows that limit L equal to limit x tends to 0, differentiation of 10x. We familiar with the formula of differentiation and integration. So differentiation of 10x is sec square x minus differentiation of upon differentiation of x square is 2x. Differentiation of x square is 2x. Now here at the point x equal to 0, denominators becomes 0. What about numerator? What about numerator? Here sec 0, and we know that cos 0 is 1, therefore sec 0 is also 1. So sec 0 is 1, cos 0 is 1, so and 1 minus 1, that is 0. So again that will be in the form of 0 upon 0. Therefore that is required to differentiate numerator as well as denominator for finite limit. So again apply L'Hospital rule for the same. So limit x tends to 0, differentiation of sec square is nothing but 2 sec x into sec x tan x. 2 sec x into sec x tan x. Minus differentiation of cos is minus sign. So minus minus will be plus. So that is sin x. Upon differentiation of 2x is nothing but 2. Remember, denominator is equal to 0, then we check numerator. If numerator is also 0 at the point x equal to 0, apply L'Hospital rule, differentiate denominator and numerator with respect to the variable, and again check the value of the given function at that point x equal to 0. If answer is finite, our procedure is stop. If answer is not finite, our procedure will be continue. So here denominator is not equal to 0. Why? Denominator does not contain x. Therefore denominator is not equal to 0 at that point x equal to 0. So therefore we can direct substitute the limit in the given function. So here sec 0 answer 1, sec 0 answer 1, tan 0 answer 0. Remember x tends to 0, so that is 2 sec 0 into sec 0 dot tan 0 plus sin 0. Sin 0 is 0 upon 2. Done. So what will get the answer? So that is, will follows that L equal to, here sec 0 is 1, remember 2 into 1, sec 0 is 1, now tan 0 is 0 plus sin 0 is 0 divided by 2. So what will get answer? 2, 0 multiply something 0 into something 0. 0 plus 0 by 2, we get answer 0 by 2, so that is 0. So our finite limit is 0 of the given function. So that is the application of L'Hospital rule when at that point x equal to something, means any real number, we can have our numerator and denominator both are, or either numerator or denominator may not be finite, then L'Hospital rule is work is taking a differentiation of numerator as well as denominator with respect to the variable, and the function will be a form of finite limit. So that is the application of L'Hospital rule.